This is Module 3, Topic 1, Lesson 2 through 3. We're actually only doing one page with this, though. We are going to be doing M3-37, and we're just going to be doing number 1 on the practice. So it says, set each given expression equal to 7 parentheses x minus 2 minus 4x plus 14. Determine whether the equation formed has no solution, infinite solution, or a solution of x equals 0. So basically, it's kind of like multiple choice. We just have to match these up with what they are. The nice thing about figuring out if it's no solution, infinite solution, stuff like that, is a lot of times you can see that like really early on. So let's get started with this first one. Now, a lot of you are going to want to jump to getting rid of these fractions, but we can't do that until we set it equal to this expression. So let's write out what that looks like. So that's what that whole thing looks like, setting this one equal to that one. So we can get rid of these fractions now, but we need to multiply everything by the same thing. So if we multiply everything by 6, that will get rid of this 2 and this 3. So now we're just going to distribute, and then we're going to combine like terms. So if I distribute this 3, when we're distributing this negative 2, the negative goes with the 2. Distribute the 42. And then everything else stays the same. So now we're just going to combine like terms, but you can only do so on either side. So the 24x and minus 2x, so we have 22x over here, 12 minus 12, so that's just 0, so those are going to go away. On the right-hand side, I have 42x minus 24. So that's 18x. And then I have negative 84 plus 84, so those will cancel out because that's just 0. So you can already tell that something special is happening here because we just have x's on both sides. So now thinking about our options, no solution, infinite solutions, or x is 0. Well, of course, I'm noticing that like if I put 0 in for these, like that's just 0 equals 0. And that's true, so that's okay, that works. So in this case, x does equal 0. So now I'll do the same thing with the other problems, just to figure out, so now our options are no solution and infinite solution. So we'll set these equal. Yeah. We don't have any fractions to get rid of this time, so that's nice and easy. We'll start with just distributed property. Also distributing the 7 on the other side to both parts. And then combine like terms on each side. So 2x and x, that's 3x. That negative 2 stays the same. The right-hand side, we have 7x and negative 4x. So that's just 3x. And negative 14 plus 14, those cancel out. All right, so noticing I have a 3x on either side. So remember our equal sign is like a scale. So if I have something on either side, you can remove it and it will keep things balanced. So if I remove the 3x from both sides, I have a negative 2 on the left-hand side, and I don't have nothing on the right-hand side. I have a 0. Then looking at that, negative 2 does not equal 0. So this is a no solution problem. And then obviously the last one needs to be infinite solutions. I'll go ahead and work that one out so you can see why that should be infinite solutions, and we can double check that they did it correctly and that really should be the solution. So we'll set this expression equal to the initial expression. Again, we don't have fractions to get rid of, so that's nice and easy. We'll start with distributive property. And then everything else not part of that distributive property stays the same. Distribute out that 7. And everything else stays the same. Okay, combine like terms on either side. Negative 9x and 12x is 3x. 12 and negative 12 is 0. On the right-hand side, 7x minus 4x, that's just 3x. And negative 14 plus 14, that's, 0. So I have 3x equals 3x. Now, some of you might want to jump to this is equaling 0 again, and it totally could equal 0, but it could also equal 1, because 3 times 1 equals 3 times 1. It could equal 2. It could equal 5. It could equal anything. Any number I put in here, because on both sides they're multiplying by 3, they're going to be equal to each other's. So this is infinite solution like we thought it would be.